live. Thank you. I love an answer back. So my name is Carly Richmond, and today I'm here to talk about two things that you probably didn't think were going to go together. But firstly, quick show of hands for me. Who has heard of synthetic monitoring? If you stick your hand up in the air. There's a few of you, okay. What about synthetic end-to-end testing, the other thing we're going to talk about today? Okay, there's not that much overlap between you two groups. This might actually be a useful session then. So I'm going to talk about both of these things today. So we'll establish a common definition for those of you who kept your hands down for both. And we'll talk about how if we use a common tool set, which in my experience as an engineer before, we don't. In this case, I'm going to use Playwright, Elastic Synthetics, and GitHub Actions. We can actually utilize the same artifact for both of these things using a technique known as monitoring as code. But firstly, obviously I've mentioned my name, but it would be rude not to introduce myself a bit more formally and also talk about, why I'm the person to explain this, what experience I have that's relevant for this argument. So my name is Carly Richmond, as I said. I'm a principal developer advocate, and as of a few months ago, took over manager responsibilities of the advocate team as well. So I'm having a really fun adjustment at the moment. I'm a front-end engineer by background. Before that, I worked at a tier 1 investment bank for about 10 years. If you want to know which one, come and speak to me afterwards. I don't bite. And I hang out in all sorts of places on the interweb. So we will have a bit of time for Q&A at the end, but if I don't get to your question or you think of something afterwards, the handle's up there along with LinkedIn. That's the best places to get a hold of me. But firstly, we're going to take my DeLorean and go back in time. We're going to go to the year 2011. I'm going to show my age a little bit. 2011 was the year I got my first graduate job as a software engineer. But it was a bit different to what you normally expect because I was more than just an engineer. I worked in the regulatory space of this bank, and I worked on an application where I had to do everything, and I mean everything. I wasn't just the engineer building the features or performing basic tests. I had to coordinate UAT. I was first, second, and third line support, including having some very vivid memories of trying to debug issues at 5 to 10, 5 minutes before the regulatory portal closed. That's definitely going to get you good at production management. I was used to juggling that, but it's a very different situation for most people. And in fact, I saw an opposing side of a balance as well, because this was the time when we had support engineers starting to take over those support responsibilities from me. And again, it was a fine balance because we were working together. I was learning from them best practices on monitoring the application, tweaking the thresholds and all those things to make it easier for them to detect issues in production. Meanwhile, they were documenting all of the information that was stuck in my head about how this application worked, diagnosing and fixing common issues, and actually wrote a lot of the knowledge article base that they then used for supporting it. Now, that's not usual. What's usual is probably a bit closer to this. Does this rock'em sock'em robot situation resonate with anyone? I'm hearing some grumbles. Maybe, maybe not. Maybe you're nicer than some of the people I've worked with. I'm kidding. Quite often, there's a lot of conflict. Not necessarily in terms of we're going to go for a few rounds in the boxing group. More around disagreements, more around passing particular things back and forth. And if you're lucky, you might have testers in the picture, but certainly for me, I didn't have that. Even when I moved on to other roles, we didn't tend to have a lot of dedicated testers on the team. And you can't rely on users to pick up every defect. Now, software is changing, okay? We've got all these new roles that have appeared. We've got SRE, which is not just a substitution for support. It's actually a very different role. The word engineering is in there for a reason. But we've even got more coming out, DevOps engineer, and now with the emergence of AI, we've got things like prompt engineering. And that doesn't make this job any easier. It means that there's more tools around. It means there's more techniques and practices around. And we still haven't learned how really to work together. Shifting left. We've all heard of shifting left? More hands, maybe. Shifting left is the paradigm, quite simply, where we're trying to push practices that are traditionally associated with later in the traditional software development cycle, thinking about different types of testing, infrastructure management, those kind of things, and pushing them to earlier in the cycle. So infrastructure as code, monitoring as code, all form parts of this because you're trying to define them earlier. And it allows us to potentially have benefits such as reproducible production and non-production environments that we can test things on. But it's still hard. for several reasons. Now, one of the reasons that I saw firsthand working in a large organization that people still tell me about is those walls associated with SRE, production management, and software development are still there. You know, our applications over the course of years have naturally progressed to follow the Conway system, and that means it's actually quite difficult for these teams to break apart. And by having these walls, that makes not just communication difficult, but empathy as well. It's very difficult for an SRE to necessarily understand a lot of the pressures when it comes to crunch time as a developer at the end of a sprint when you're trying to get that thing finished because the product owner said it had to be finished in the middle of the sprint and you're now getting to the end of it. We all seem to see that thing happening. And then on the opposing side, developers quite often were not that great at building maintainable, supportable applications. So SREs are finding loads of optimizations, toil, and opportunities to try and make the application more reliable. But when they're finding these things, the prioritization is still different. And if the prioritization is still different, does that really mean we're going to be able to have a common discussion and agreement? No. It's not just the SRE point, it's also the product manager point. If we think about using scaling frameworks or Scrum and having that product owner role, quite often they're going to understand a new feature because it has a business purpose and objective and probably corresponds to some business goals. That fix might not. And for those reasons, it can be really difficult to try and really communicate what the priority is and establish an agreement. Now, we all take shortcuts. We all put things on the back burner that maybe we shouldn't. We had a talk earlier where someone was talking about, you know, upgrading from Angular 10 to 17. I literally, just before I left, was still working with stuff that was on Angular JS, shock horror. Quite often we're putting things onto the back burner, we're putting quality to the side because we're just rushing to get that new thing out. And that means that we can paper over the cracks and never come back and fix them. But you know what? These are all cultural issues. There's one thing that's in our control that could probably help with some of these, and it's the fact of tooling. I talked about those different tools. I've talked about those different roles. We are all using different tools for the same thing, which is where my argument comes in. My last role working as a software engineer, I was using Cypress for writing end-to-end tests. So for those of you earlier that didn't raise your hand, end-to-end tests by definition are where we have basically a test that will automate the user workflow. So those clicks, text entry, things like that that people are doing on a web page, it's going to automate that to make sure that that workflow is going to operate as expected through the application. Now this might most likely mean that it's going to touch the application layers and show the integration between, for example, your front-end Angular application and your middle-tier Java service. But you get the idea. It's allowing us to see what's going on and if that workflow can actually be achieved by a user. And it's quite useful when you think about combining it with behavior-driven development or even test-driven development practices. Because that way we can really test using an end-to-end test that what we're building is what's expected. But then we've got synthetic monitoring, which a few of you didn't have your hands up for either. So we need to establish a common definition. So synthetic monitoring is where we have some form of script that is running against our application on a fixed schedule in production to make sure that not just a service is alive using a ping against a health actuator point, but also simple things like checking that a user workflow is accessible and available by doing those same clicks and text entry that I talked about in end-to-end tests. So my last role in a bank, I mentioned I was using Cypress. In my time, I've used all sorts of other different end-to-end testing frameworks, including, unfortunately, Protractor. Has anyone used Protractor, perchance? Do you miss it? Yeah, there's a reason we're all shaking our heads, isn't it? So I was using Cypress and happy that I'd left Protractor behind, the same as yourself. But when it came to synthetic monitoring, I had SRE colleagues that were using Selenium. And the reason they were using Selenium for their synthetic monitors is because they could easily convert and upload them into Pika, which is what they were using for their monitoring of production. So here we have a situation where we have two teams that are not sitting that far away from each other, just a phone call away, even though it's a big company. And we're using different tools both to automate the user perspective. That makes no sense to me. I think we should try something else. I think we should try and find a common tool that allows us to work together. Now this is easier said than done because we've talked about the complexities around talking to each other. But I'm going to talk about an example flow here. So I'm going to talk about using Playwright for JavaScript, which is an end-to-end testing and automation framework maintained by Microsoft, alongside GitHub Actions, because we need to validate these monitors. We're using a monitor as an end-to-end test as well, effectively. And then I'm also going to show how it works in Elastic Synthetics as well, where we can actually see the same definition running in production. Now, I know you won't all be using Elastic, and that's okay. If you take one thing away at this point, it's that you should go off and check what automation framework is compatible with your observability provider, and potentially use that for the same common definition. So it might be Selenium, it might be Cypress, it might be Playwright. But hopefully, you'll have some form of common definition that you can use as a code artifact to automate those user journeys. There are recorders. Certainly some allow you to record the settings in the browser, but the problem with that is that you've not got it as a code artifact that can be changed and can be easily included into the process. So before I dive into the code, let's talk about each of these pieces and how they communicate together. Okay? So I've got this diagram up here to try and show where each of these elements communicate. So the first thing you're going to see way up here is I've got a project that's got TypeScript and JavaScript journey files. Now, I'm using TypeScript for the purpose of this. I quite like TypeScript. Most people do, some people don't. JavaScript is fine. The point is you've got a project where these monitors are going to live that's going to use Playwright. You've then got GitHub or whichever CI. And what's going to happen in there is you're going to have the monitors run as an end-to-end test as a pre-validation for merging. Because we need to make sure that these monitor definitions are lining up with the version of the code that's eventually going to be deployed. If you end up in the situation where they're not in sync, you're going to end up with your monitors failing in production and potentially raising alerts and causing all sorts of chaos. We don't want that. In both the local development and the GitHub case, they're going to be running against some form of local app. Then on merge, when we're going to deploy our app, we will use API key authentication to push the monitors to the infrastructure they're running on, which is either Elastic, or you can run it yourself using Fleet and Elastic Agent. And that's going to ping the production web app because we have configuration that, depending on the environment, is going to be able to say you need to ping local or you're going to ping my production app. And from there, it's going to basically store all the telemetry information regarding the success and failure of the runs and some other metrics and stats inside of Elasticsearch that you can search on top of. So this is the little toy app that we're going to instrument today using a monitor. So it's just a little simple vanilla web app. I wrote it in Svelte if anyone is curious. I thought I'd have some fun and try out a new framework. And we're going to automate that particular manual authentication flow. Now, I know the next question someone is going to raise at the end if I don't cover this. What about if I'm using an automated mechanism such as OAuth 2 tokens? I haven't covered it in this talk, but I do have an example that shows you, that I'll reference at the end, that shows you how to do that. But basically, you'll get some form of dummy token and then use that to authenticate the flow. Right, so let's dive in. This is a test. This is a sample Playwright test. So a quick show of hands. Who is familiar with Playwright? Who has used Playwright? Okay, there's a few of you. So for those who haven't, we'll walk through it a little bit slowly, so we'll just take our time. The ones in the audience have put their hands up, though, you can keep me right. So what you'll see is I've got a single test that I'm including in here for a successful login. The first thing I'm doing is I'm going to my login page. All of the interactions that we do within Playwright are against the page object. So all the clicks and the text entry, all done against the page object. You'll see that I'm using this locator shorthand called get.By test ID. There's a series of shorthands for particular common attributes that you might use to locate particular elements. So ID, test ID, things like that. If you're wanting to use a longhand expression, you can just use page.locator. Now, I prefer using data test ID because I've had nightmares from my protractor days. If you end up coupling the locator logic to the CSS classes that you're using in your styles, what's probably going to happen is you're going to end up with tests that are flaky for reasons other than potentially concurrency. They're going to break on a regular interval because whenever you're changing stylings around, whenever you're moving elements or restructuring a page, you're going to break your test and you're going to have to go and tidy up all the locators. So save yourself some pain, extract it out and use a data test ID attribute to access those HTML elements, because it kind of has test in the name and screams, can you please not touch this? So from there, I'm checking that the submit button's disabled because I've disabled it by default unless the user has in fact entered the username and password. Then we use fill on the input element to add in the appropriate username and password. Now, I'm going to be explicit here. Please don't use production credentials in your tests. Please don't use production credentials that can do everything and destroy the world in your synthetic monitor either. You need to think about the worst case where this potentially is going to get out. So if anyone's got any more detailed questions, we can discuss after. But generally, using a particular account that's tied to particular test attributes, for example, dummy test cards and things like that, is the way you want to go with these credentials. From there, I'm checking the submit button's now enabled because I've now got, the username and password populated. And from there on click, I'm checking to make sure that I actually navigate to the page that I want, which is the welcome page. So it's a pretty simple test that most of us would write. But I want to convert it into a monitor. And for that, I need some configuration and a few other bits and pieces. And the easiest way to generate that is by using this synthetics init. So this wizard passing in the test project is going to generate a project that looks a little bit like this. So you'll see the journeys folder, that's where these monitor definitions are, and you can already see up here that I've got several examples. There is a lightweight folder which has heartbeats for, pinging services that are based in YAML. We're not covering those today, but they're there. Then finally, I've got my package.json where I have generated the commands for running the tests and pushing the key. And then I've also got the synthetics config where my configuration for these monitors is going to live. Now, within the config, there are several sections. So we've got params, as you probably guessed, these are the parameters that are going to be passed into my test. So that username and password, for example, potentially. But also the URL from localhost. That's the one that I've defaulted. However, if I can cast your eyes to scoot all the way to the bottom to line number 33, what you're going to see is that when the environment is production, so this is leveraging the node environment in which we're running, it's going to change the URL to be my production version, and that means that the appropriate URL is going to be passed into the monitor when it's running in that particular environment. I'm able to pass in particular Playwright options, so I've got an example there about ignoring HTTPS errors, but a common configuration you might want to put in this section is perhaps for device emulation, for example. So if you want to emulate particular devices, maybe Android and iOS handsets to make sure the application is behaving in each of those environments, that's where those go. You'll see I've got the default monitor settings because we specify a default, and then if you want, you can override it in the monitor underneath. And here I've said that the schedule is going to run every 10 minutes. I'm using the UK Elastic infrastructure. I don't have a private location set up, but if you do that, it's basically a case of installing Fleet and Elastic Agent, and then that will run the monitors from the location of your choice. And you just need to specify in there what that location ID is. And then it needs to know which Elastic cluster to send to, because otherwise, well, we're not going to be able to ping the monitors from Elastic. And that's basically the configuration. Now, you're probably wondering, how is your test change? And it might look a bit scary because you probably can't read that even from the back row. But if I zoom in, what you'll actually see is that not much has changed apart from we split our test out into a couple of distinct steps, because that corresponds to the individual steps that you'll see in the monitor when we get to that particular point. So I'm using a journey here, passing in the Playwright page object. It's the Playwright page object, trust me, and the parameters that are coming from the configuration. I've overridden the monitor settings. You don't need to do this if you want the default. And then I've set that the before step is I'm just going to go to the page that's being passed in via the params URL. And then for each step, everything is the same. The only difference is I've split it out into a couple of steps. So you can see that this is the login step. You can see here as well that I've got the actual text entry step as well. And that's pretty much it. I like that because it kind of aligns to my prior experience of doing a lot of behavior-driven development. Is everyone familiar with behavior-driven development? Okay, a few hands as well. Great. So for those who haven't, basically, behavior-driven development is the idea of using English-like syntax to have a behavior-driven specification for your test. Quite often, tools like Cucumber, etc., would use the given when then syntax. And I think for splitting things into individual steps, like you have with a journey, that works quite well in my head from my BDD days. So what we're going to do next? Well, we now have a monitor that runs locally. Hopefully we're doing some form of test-driven development to make sure that our feature passes against this. And from there, we're going to run it as part of our CI. So there's two things that we want to do. We said we wanted to use these as a gating condition for merging changes. So you can see up here that I specify the node environment as development. I've then got the username, password, and I've just put the JUnit file there for, ease. And from there, I'm starting the application. Obviously, if you're running it via Docker or whatever, that step gets substituted. That's totally fine. And then I've actually run the synthetics command rather than just the test command to show the difference using the JUnit reporter. And you've got to run it within the journeys folder because then it will pick up all the tests. And from there, I'll then publish using this kind of reporter here. So I can then actually see which of them are passing and failing, which is exactly what I would have done with an end-to-end test when I was a developer. Here comes the bit that's a bit different. I need to push these definitions when I go to deploy my application to make sure that the application and the monitors are in sync. So from there, what you need to do is specify the node environment's production. So I've got up here, you've got the username and password, and I've got my synthetics API key. Obviously, I'm putting the key in a vault. Please don't put your public key inside of a public GitHub repository workflow. And you'd be surprised the number of times I have to say this. You all seem like lovely people, but I'm not going to give you my key. Sorry. So from there, what I'm doing is basically running the push command, which is going to push the monitors to that Elastic cluster based on the configuration in the project file, and that synthetics config file. And that means I then have a set of monitors that are going to run according to the schedules that I've defined that will either be passing or failing. So we can see here you've got one above on there that's a bright red with a big warning on it. That's the one that we're going to have to go and investigate and see why that's failing. But it also means we can start to do smarter things with that same definition because we can see how long each step is taking. So historically, I used to have problems with end-to-end tests where they just seem to get longer and longer and longer. And that could potentially be because the features become more complicated, but in all likelihood, it's probably due to a performance factor. So being able to see if the duration of the test suite is taking longer, also looking out for timeouts, which in protractor days was pretty normal. In Playwright days, less so. You can see how long things are taking and then perhaps use that as an indication of maybe something's not right and I need to have a look. We can then do smarter things still. So I can show here a failing test. I can see what the particular error is. You can also see duration by step. So again, I can see exactly which step is taking longer. And then I can do smarter things still. Maybe I want to send an alert. Now, I wouldn't recommend sending an alert for every single failure. That's just not smart, because in all likelihood, you might end up with a situation of recovery. So you might want to look at saying, well, it's failed this many times in X amount of minutes. Maybe I need to alert someone and a human needs to take a look at this. But then we can also potentially tie it to burn down rates in SLOs, for example, which is also possible to do. But one of the other things I like is that it actually gives you the metrics for each individual step. So how many people are familiar with Google Core Web Vitals? One person. Okay. To be fair, I kind of expected that. So Google Core Web Vitals are a set of performance metrics for classifying websites. Typically, you would probably use a tool such as Google Lighthouse to generate a report to see what these metrics are. They're not infallible by any means, but they can give you a rough indication on perhaps slowness or lack of responsiveness of a website to user input that you can try and fix earlier. And being able to see those metrics, so that's the LCP, FCP, CLS ones that are sitting in here. Seeing those and maybe tying them with a RUM agent or some other form telemetry can definitely help you see if there's something up with the site. Now, I'm not going to say it's going to catch everything, Because unfortunately, as I've seen, users use your applications in ways that you do not expect. And that's often where I find a lot of errors come from. But when they shout help, one of the good things with these definitions is you can use it to start at the beginning. You can recreate their issue potentially using one of these monitors by writing a new one, automating the steps that they've done to cause the failure, and then using that as the artifact to develop and deploy the fix. So, we've talked about synthetic monitoring, we've talked about end-to-end testing. Now everyone knows what these things are, and everyone knows that you can use Playwright, Elastic Synthetics, and GitHub Actions in order to automate that flow and use a synthetic monitor as an end-to-end test using monitoring as code. And we all know what all those definitions are now too. The whole point of this is going back to that original story I had in my last role when I worked at a bank. We're very often still, even 2-3 years later, using different tools depending on where in the organization we sit. And that still doesn't make sense to me. And for those reasons, I urge you to go and look at the possibility of using common tools, talking to teammates in different teams, and trying to find ways to automate the same definitions where you can. If you want to learn more, I do have a QR code at the end, so don't panic if you miss these, or you can snap a photo, it's all good. The first link, that refers to the GitHub project where all of this code is. The second one is a piece that I wrote for our observability labs on Elastic, which covers how to create one of these in detail. And the third one, that's that one authentication example. So if anyone's interested in how to utilize this with OAuth 2, that's the example I'd recommend taking a look at. But with that, thank you very much. It's been a pleasure, Antwerp. If you're around tomorrow, we are having a meetup. Feel free to come along. We're a friendly bunch, I promise. And with that, thanks again. I have 3 minutes, so I have time for one question. Does anyone have one? Yeah, sorry.
Yeah, so what if you wanted to monitor the production environment without being able to see all the data that's in the production environment? An example is that I have a team that is looking at data for many people in a municipality, but we are technically not allowed to see the data that is on the client's session.
Okay, I understand. So the question is, how do I access these monitors without being able to see the data because I have a particular data situation that means that I can't see production data?
Correct.
You're the first person to ask me that. Thank you. Let me have a quick think. This might be a situation where you have to deal with role segregation, sadly. It might be that you can still use the artifact as a common definition, but your development teams just don't have access to the observability platform, which means that they won't be able to see the screenshots.
Right.
That's probably the way that I would handle it. And to be honest, from my banking days, I didn't have persistent access to production for that very reason, and that's how we handled it. So that's probably what I would recommend. Does that make sense? Okay, one more, yes?
So from front-end perspective, this shows us availability and both web vitals. Is it possible to also further extend this with back-end traceability? Like we could integrate this with any APMs or not?
That's a fantastic question. So the question is, can you extend this to utilize back-end tracing? So you're absolutely right. This, as a synthetic monitor, is showing you the more of the front-end perspective and making sure it's the user perspective and the applicability of all the layers. If you're looking for APM tracing for front to back end, what I'd recommend is you need a different tool set. So for the front end, to capture core web vitals and the front end tracing, you need to look at using a real user monitoring agent or a RUM agent. And then back end, you can combine that either by using the vendor specific APM agent, or to be perfectly honest, I'd recommend OpenTelemetry. And there's the deep dive from this morning where they cover OpenTelemetry in great detail. So you can hear about that, or you can come to the meetup tomorrow where I'll explain what RUM and APM and OTel all are. All right, everyone, that's us. Thank you very much, and I'll catch you in the hallway track.